Hi, good evening, everyone. Good evening. Welcome to day 9 of the live session. I hope I'm audible. Just let me know in the comment box if I'm audible. Okay. All right, guys. So today we have today's day 9, and till now we were doing questions. We were discussing a lot of questions for IIT JAM, CET from various subjects. So today we are going to study a very important topic of mathematical economics. तो मैथमेटिकल इकोनॉमिक्स का एक बहुत इंपॉर्टेंट टॉपिक है विच इज लिमिट्स एंड कंटिन्यूटी. So limits and continuity from mathematical economics is one such topic from where you will always get questions in IIT JAM exam, in CET exam, in GATE economics, and even the other examinations we talk about when we talk for MA entrance. So it's a very important topic. So today we will be starting with the topic. So I will be teaching you limits ka topic, and then we will be doing question based on that. Okay? So ready for the class? If you are ready, send me thumbs up. Quickly send me thumbs up. Let's start. Okay. I hope I'm visible. Can you see me? My screen is also visible to you, right? ठीक है. Chalo, let's start. Before I start, I would request you all to keep your pen paper ready. Notes zarur banana. We will be. This is the first lecture on limits and continuity. So instead of doing everything in limits and continuity, what I will be doing is I will be teaching you the stuff from which the syllabus, the questions come from. Right? So no idhar udhar ki baat, just सीधी बात we will be doing. So if you are preparing for IIT JAM 2026 for economics, GATE economics, UAT PG economics 26, so the we will be taking of course more than one class on limits and continuity. तो अगर आप ये सारी classes देख लोगे limits and continuity की, तो you will be able to solve question. That's the purpose here. So the purpose is not to teach from a textbook, but the purpose is that if you watch these videos where I'm teaching limits and continuity, so you will be able to attempt questions. Even we will be attempting questions from past years as well. So today is day 1. What is today? Today is day 1 of limits and continuity. But this day 1 is day 9 of the MA entrance series. ठीक है, day 1 of limits and continuity and day 9 of us studying together. ठीक है? All right. So let's begin now. Now, what happens is when we talk about limits, what do we mean by limits? When we talk about limits, what do we understand by the word limit? So, in very generic language, if we talk about the English language, then limits mean that when you are getting closer and closer to something, maybe that can be a maximum limit, that can be a minimum limit. So, you're getting closer and closer to something, but you're still not touching that. Yes, you're still not touching that. So the idea of limit is always about that you get closer and closer to something, but you still do not equal to that. In maths, we don't say touch it, we say that you're still not equal to that number. Okay, so we understand the concept of limit, we study the concept of limits for solving the questions based on that. Limits is always taken for our functions. Why? Because what happens is, many times when I talk about function f of x is not defined, the value of function f of x is not defined for a particular value of x, for a particular value of x. So in that case, what happens? In that case, we try to find out that, okay, if x is near to that particular value, so how is f of x going to behave? For example, when x was equal to a, so f of x was not defined. f of x was not defined. मुझे नहीं पता f of x की क्या value आएगी. So what I'm going to do is, I will see कि okay, how my function is behaving. How my function is behaving. Okay. How my function is behaving when x is near to a. So let's say this is near to a. This is the region where x is near to a. So I will see ki how the function is behaving in this region. So maybe that has something to tell about f. That has something to tell about the function when x is equal to a as well. So that is the approach, that is the notion of limits. So how do we study limits? How do we study limits? We say limit of a function f of x when x approaches a number is equal to L, let's say. So how do we read it? Reading, the way you read is very important. बहुत सारे लोग होते हैं, if I give them a complex question of limits, वो solve कर लेंगे, लेकिन they don't know how do we interpret that, they don't know the meaning of this. So you should not only focus on solving questions, but you should also understand things. Okay? So how do we read this? We read this in the following manner, that when x approaches a, f of x approaches L. So when x is near to a, the function is near to L over here. Now when I talk about x approaches a, what does this mean? X approaches a basically means that x is coming closer and closer to a. So x is a value which is closer to a, maybe in this circle, let's say. Maybe in this, maybe in this area over here. X is closer to a, so x can be a part of this circle, this area. Now, in that case, x can be on this side, x can be on that side as well. Yes, you agree? X can be on this side, x can be on that side as well. So when x comes from this side, when x is approaching a from left side, on the left side, you have numbers less than a. What do you have? You have numbers less than a. So on this side, x approaches a where the numbers are little less than a. So I put a negative here. Negative represents that you subtract something to get here. So this is the left hand side limit. But when I talk about the right hand limit, right hand side, so at this place, the numbers will be little, very smaller, greater than a. So x approaches a plus. For example, यहाँ पे a है, यहाँ पे a.001 है, and यहाँ पे a minus 0.001 है. Let's say this. ठीक है? And on this side a plus 0.001 है. So that is how it's closer to a. ये a के इतना close होगा. ऐसा नहीं है कि if I'm saying कि a is equal to let's say 2, अगर मैं बात करूं कि a जो है वो 2 है, तो on this side x can be 1.999. On this side this can be x can be 2.001. It will not be on this side it will be 3 and on this side 1. नहीं, इतना दूर नहीं होता. The difference is very minor, very close to 0. The difference when I say x approaches to a, तो x equal to a तो नहीं है, लेकिन बहुत minor difference है, very closer to 0 as well. That's how we interpret the limits. ठीक है? अब now understand one thing. If you're working with a polynomial function, in that what you can do is you simply put the value of x equals to a and you get the answer. बहुत बार ऐसा होगा that when you put x equals to a, you will not get any answer. तो उस केस में you have to solve for common factors, और आप limits को solve कर सकते हो. For example, let's take one case. So let's take us one case. I'm saying limit x approaches 1 and the function is x square minus 1 upon x minus 1. देखो, over here, if I put x equals to 1, the function will be 1 minus 1, 1 minus 1. This is 0 by 0, which is not defined. Function defined ही नहीं है at x equals to 1. So what do I have to do in this case? I have to cancel out a common factor. I have to cancel out a common factor. Now what is that common factor is? वो हमें देखना पड़ेगा. That I have to see. So सबसे पहले I'm going to simplify this limit. Limit x approaches 1. X square minus 1 को I will write x minus 1, x plus 1. And in below again x minus 1. X minus 1 से x minus 1 cancel. So x plus 1 is left here. Now if you put 1 in place of that, it will become 1 plus 1, which is 2. Now I have got the answer that this function will be closer to 2. This function will be approaching 2 when I cancel the common factor and when I take the limit. तो इस तरीके से बहुत बार when the function is not defined at a particular value, you have to take limit and solve in this following manner. So there are numerous ways. But if I now say, let's say, if I now say, okay, limit x approaches to x cube minus 5. So is the limit defined? Yes. You simply put 2 in place of x. 2 cube minus 5. 8 minus 5. 3. So yes, limit is directly defined. I don't need to do anything to my function. But the most easiest form you have to solve is cancelling the common factor. You can many times cancel the common factor and you can get the value of the limit as well. You can get the value of the limit as well. ठीक है, अब ये तो हो गई simple सी limit. That's one very simple limit. Now we will be studying another 2 ways of solving limits, which are very important for your examination. Very important types of limits. So we are doing something very important. Most probable questions come from this section. Okay, what is this section about? So in this we study 2 types of limit. First we have seen that I can put the value directly or I can take a common factor and cancel it out. So usse my limit will be solved. The second, the next 2 types are infinite limits, okay, and limits at infinity. Limits at infinity. That's what we have. This is limits at, not and. This is at. Now these 2 words confuse every student a lot when they study it for first time. But आपको नहीं confuse होना. Okay, so we have a query in the chat box. Ma'am, could you please take a minute to tell from where to start limit and functions and derivation of someone who haven't studied maths in 11th, 12th? देखो, student, देखो, what happens is even if you have not studied limits in 11th, 12th, functions in 11th, 12th, functions I have already taught in one of the lecture. तो आप उसको देख सकते हो, वहां पे आपको समझ में आ जाएगा कि what are functions. Talking about what I'm teaching today, even if someone haven't studied maths in their 11th and 12th, उनको आज का lecture समझ में आ जाएगा. It's very basic I'm doing. मतलब I started from basic. मैंने starting से बताया what is limits, how to solve that. Only then I have come to the exam important portion, right? So even if you haven't studied, but yes, if you want revision, and if you're enrolled with Ecoholics, then though your study material contain all the necessary information, or classes में भी हम detail में करेंगे from basics. Again, if you're not enrolled at Ecoholics, in that case, you can go and refer to NCRTs as well. You can also contact us. I'm writing the number here. You can contact us. We will share some study material for you to revise your maths basics. ठीक है? So this is the number, आप इस पे कॉल कर सकते हो या मैसेज कर सकते हो. I will share some material for you to read, जिससे functions and limits continuity बहुत easily you will be able to cover. All right? Infinite limits, limits at infinity. Now, what are these two concepts? These two are completely different concepts. You don't have to get confused in them when a question comes around them. बहुत ध्यान से you have to solve a question related to this. So infinite limits mean when the function approaches infinity. Infinite हो जाता है when the function is near to infinity. Infinite हो गई limit. Limits at infinity means x approaches infinity. So limit you have to find when x is at infinity. ठीक है? When x is at infinity. So दोनों different चीजें हैं. इसमें f of x infinite हो रहा है. इसमें x is becoming infinite. So if we first talk about infinite limits. Infinite limits. The standard limit we study in infinite limits is limit x approaches 0, 1 upon x square. Now tell me what happens. When x approaches 0, 1 upon x square will be 1 upon 0, which is infinity. So this is the most standard form of infinite limits. Remember one thing over here. What do you have to remember? One thing. Many students write limit x approaches 0, 1 upon x equals to infinity. This is wrong. You cannot write this. Why is it wrong? I told you the concept of left hand side limit and right hand side limit. Only when both left hand side limit and right hand side limit are equal, we say the limit exists. Matlab the function has a limit there. You can solve the function there. So when I now talk about this, देखो इसमें left hand side limit means x approaches 0 but from the left side of 0, which means x can be a negative number closer to 0. So in that case, because x is a negative number, so 1 upon, but it will be very close to 0, such as minus, let's say minus 0.001. So minus की वजह से I am going to get minus infinity here. And when I talk about right hand side limit, so x approaches 0 but from right side, which means numbers will be little bigger than 0 and hence positive. So इस case में 1 upon x is infinity, positive infinity. So because left side is minus infinity, right side is plus infinity, I will say that the limit does not exist. That is why we take x square over here. इस वजह से हम यहाँ क्या लेंगे? X square we are going to take here. ठीक है? X square we are going to take here. Is it clear? So these are very simple limits. जहाँ पे भी you see कि okay infinity is becoming, so that is an infinite limit. For example, if we solve just one question here, limit, let's say I say x approaches to x minus 3 upon x square minus 4. अब इसमें भी infinite limits में always check left side and right side. Always do that. ठीक है? क्या करना है? Always you have to do that. अब इसमें left hand side limit को if I solve over here, it will be limit. Okay, I will take a little thinner pen. Limit x approaches to minus. So x minus 3. Okay, now tell me. If you have a number little less than 2, तो x minus 3 तो negative आएगा. Negative number it will be. And x square minus 4. Now because I'm talking about the left side, जहाँ पे numbers थोड़े छोटे हैं 2 से, तो x का square 4 से थोड़ा छोटा आएगा, तो you're going to have a negative number closer to 0. तो negative and negative क्या हो गया? Positive, but because a number is closer to 0, so you're going to get infinity, positive infinity, because negative, negative, positive. But when I talk about right hand side limit, so right hand side limit में limit x approaches 2 plus, so x minus 3, x square minus 4, that's what we have to study. So again, if you have a number little bigger than 2, let's say 2.001, so that minus 3 will still be a negative number. But because now you have a number little greater than 2, so the square will be greater than 4. It's very simple. देखो x is greater than 2 on right side. So x square will be greater than 4. So x square minus 4 क्या आ गया? A positive number closer to 0. अब नेगेटिव एंड पॉजिटिव मेक्स नेगेटिव ओनली, बिकॉज द नंबर इज क्लोजर टू जीरो, तो ये माइनस इन्फिनिटी हो गया. तो अगेन लेफ्ट हैंड साइड लिमिट इज प्लस इन्फिनिटी, राइट हैंड साइड लिमिट इज negative infinity. That's how you need to check here. Is this clear? Now moving on to another concept, which is in limits at infinity, which is limits at infinity. Now, very important to listen. Question solve करना आना चाहिए. Just one trick I will tell you, and with that you can solve all the questions that come associated with this. Limits at infinity में tell me one thing. If I say कि okay, get me the value of this limit x approaches infinity, ठीक है, let's say 2x plus 5x square, not 5x square, let's say 2x minus 5x square. Tell me, what will be the answer? Can someone tell me in the comment section? कोई बताएगा मुझे comment section में कि क्या आंसर आएगा मेरा यहाँ पे? Yes, definitely you can text us and you can get the material. हम help कर देंगे कहाँ से पढ़ना है और कुछ PDF share कर देंगे. No worries at all. चलो जल्दी से बताओ. Anyone in the comment section? So you will say x को infinity put कर दो. Minus 5x square है, that is also infinity, right? तो infinity minus infinity तो infinity ही होगा. That is what you might be saying. But I don't know now whether 2x will be a bigger infinity or 5x square will be a bigger. Because sign कि positive infinity आएगा या negative infinity आएगा, I don't know. What if they are equal to each other? So I don't know anything. So this is a not defined way. So limits at infinity ko we don't solve it like this. So for limits at infinity, we study a standard limit. That is limit x approaches infinity. So 1 upon x will be 1 upon infinity is 0. So that's a standard limit. So whenever we have to solve limits at infinity, we try to convert every question, we try to convert every function in the form of 1 by x. We try to convert every function in the form of 1 by x. How do we do that? So the trick is take the highest power of denominator, take the highest power of denominator of x basically, and divide the entire function. Divide entire function f of x with that. That's the only trick. If you do that, the function will be converted in terms of 1 by x. So either you have 1 by x or something by x. The only thing that matters is that you have x in denominator. Okay, that way you can solve a lot of questions. So let's see that. Let's take an example and do it. So question number 1, let's say limit x approaches infinity, minus infinity, let's say, and then let's take 6x minus 5 upon 11x cube plus 2. Let's take this up. So what is the highest power in the denominator? What's the highest power in denominator? It's 3. So I'm going to divide the entire function with x cube. I'm just dividing the entire function with x cube. And limit as it is. Limit x approaches minus infinity. Now tell me one thing. Even if I divide 6x by x cube, so x square will be left in denominator. Okay, let me solve this here for you. This will be 6 upon x square minus 5 upon x cube upon 11 plus 2 upon x cube. Now tell me one thing. No matter whether you have x, x square or any other power of x, when x is approaching negative infinity, 6 upon an infinity will also be 0, isn't it? It will be 0. So when x is approaching positive infinity or negative infinity, it doesn't matter, you always get 0. बहुत सारे student क्या लगाते हैं, 0 के आगे negative लगा देते हैं. They think I'm going to have 0, but that will be on negative side. So numbers such as minus 0.1. But no, you don't have to make that mistake. Chahe x approaches infinity ho ya minus infinity, you will write 0 here. 5 upon x cube will also be 0. 11 plus 0. So the answer is 0 again. The answer will be 0 again. That's the only trick. That's how you solve questions from limits at infinity. ऐसे ही हम क्वेश्चन को सॉल्व करते हैं. Let's take maybe one more question. Let's take one more question. And okay. So limit x approaches infinity, 5x square plus 10 upon 3x square minus 8. That's what I have. Now, what am I going to do here? I will be taking the highest power of x in denominator, which is square again. So, I will be dividing the entire function with x square. So, 5x square upon x square, 5 plus 10 upon x square, 10 by x square. 3x square upon x square, 3 minus 8 by x square. Now, these terms will become 0 when x approaches infinity. So the answer comes out to be 5 by 3 because 5 by 3 are constant. उन पे limit नहीं work करेगी. X is not a part of them. So 5 by 3 comes as it is. वो as it is आ गए मेरे. तो answer क्या आ गया? 5 by 3. 5 by 3. Is this clear? Now, if we talk about limits at infinity and infinite limits, guys, there is one term, very important one, asymptotes, जिसके basis पे बहुत सारी चीजें पूछी हुई होती हैं. So when I talk about asymptotes, so that is a graph which does not touch axis but comes closer and closer to that. Comes closer and closer to that. For example, if I'm drawing a curve like this, so it's not touching x-axis, but it is coming closer and closer to that. Okay? So always remember, when I talk about infinite limits, when where the function is approaching infinity, the f of x, basically I'm going to have f of x approaching infinity means it will never be equal to a number, but it will be a very big number. Yes, which means on the y-axis, I'm going to have an asymptote. So because the asymptote will be formed on y-axis, we get a vertical asymptote. What do we get? We get a vertical asymptote. How does a vertical asymptote looks like? Let's see. Something like this. So it's going in the upward and below direction because of left hand side limit and right hand side limit. So here x was approaching 0. That is why the asymptote is coming closer to 0. Now if my x is approaching 2, let's say, so asymptotes will be formed here. Okay, asymptote यहाँ form होंगे. Wherever the x is approaching, asymptotes will be formed there. Okay, the center of that will be there. Now, when I talk about limits at infinity, so I'm going to have horizontal asymptotes. What I'm going to have? Horizontal asymptotes. Why am I going to have horizontal asymptotes? Because here x approaches infinity. So x approaches infinity means the asymptotes will be available on the x-axis. The asymptotes will be available on the x-axis. I hope this is clear. Anything that you want to ask from the asymptote thing, you can ask me. Okay, so it will be, let's say like this. It will be around the x-axis you're having the asymptotes. Yahan pe if you will see, they were around the y-axis. Okay, so that is limits at infinity. So for today's session, we have done two very important concepts of limits. Okay, I told you the intro of limits, and then we did the two important type of limits. Jiske basis pe you can solve questions. I have told you the tricks also. In the next session of limits and continuity, we will move ahead and we will be doing more things. We will be talking about some standard limits. We will be learning how to find continuity as well, how to check whether a function is continuous or not. So, what do you have to do before you come to the live session tomorrow, the next session? You have to go and revise these session, the today's class, okay? And in case you have any doubt, in case you want to take my help for solving any question, I'm available on the number 7880107880. You can contact me as well through this number. You can talk to me as well in case you have any doubt, you want any mentorship. All right. So I will see you guys in the next session, day 10. All right. For the updates, please follow our channel, subscribe to our channel. You will get the updates. Other than that, even if you message us on this number, we will send you a WhatsApp text once we are live, or once we will share the link of the next live session, as well as you can get more quick updates by getting be a part of our WhatsApp list. We keep sharing a lot of things if you want to become a part of our WhatsApp list. Okay. Thank you so much, Anjita. I really admire that you like the session. Okay. So we will meet tomorrow. कल भी हम एक साथ पढ़ेंगे and we will continue ahead. All right. Bye everyone.